Well, today we are celebrating another subscriber milestone, 3,003 subscribers. 3,003 is a very important number because it is both a palindrome number in base 10 and it's a triangular number in any base. Now, I know anytime you do something in base 10, people will say, oh, base 10 is arbitrary. We only use base 10 because we have 10 fingers. Well, that makes it important to us. And subscriber milestones are arbitrary as well, so we might as well put two arbitrary things together. So a palindrome number is pretty easy to understand. It reads the same way forwards and backwards in the given base. But to actually check for whether a number is a palindrome with a computer is not so straightforward. So what you have to do is first grab the number of digits. You have to know how many digits it is so that you can start extracting those digits. And to do this, we need to use a couple of logs. So we take the log of the number divided by the log of the base. This log function in GlowScript is the natural log. So to get log base anything, you just take natural log of the number you want to take the log of, divide by the log of the base. And we're going to chop off any remaining decimal places. Obviously, this is not going to be a nice integer, so we're going to make this an integer. But that means we're losing one, so we're going to take the integer part of this plus 1. And that'll give you the number of digits in the specified base. Now, the next thing we need to do is we need to start peeling off the digits of the number. So we're going to create a list that contains the digit. We're going to do that right here. So we start it with an empty list, and then we're also going to have a truncated number because as we pull off digits starting at the left-hand side and moving to the right-hand side, we need to be able to keep track of what digits are left. So here's our counter in. We're going to start that at the number of digits, so it's going to start at the left-hand side of the number, and then we're going to loop over in, and it's a little atypical for us on this channel. We're going to decrease in with each round of the loop. And then here's where we strip off the leftmost digit from the truncated number. So what we do is we take the truncated number, divide it by the base raised to the power n minus 1, and we take the integer part of that. So basically we're reducing it to where this truncated number, this digit that we're interested in, is going to be the only integer part left. Everything else will be in the decimal, and then we just chop off the decimal. And then here we update our truncated number. So we take the number we had before and we subtract off the digit that we just removed. And then, of course, we add our digit to our list of digits. So basically, this list digits here is the number that we put in separated out by digit. So the first part is going to be the leftmost digit, then the next digit, then the next digit, then the next digit in this list of digits. And so then to check for whether this thing is a palindrome, all we have to do is check for whether the digits match on either side of the middle. So we take our loop here. Now we're going to loop upwards. We could loop downwards. It doesn't really matter. But we're going to loop up along n from n to n digits. And we're going to check for whether the current digit we're looking at is equal to the digit on the other side. So for example, if this is the leftmost digit, then I'm going to check it against the rightmost digit. If this is the second to left digit, I need to check it against the second to right digit. And if any of those fail, then I don't have a palindrome. So we're going to start by assuming that we do have a palindrome. Then we're going to move down here and say that our palindrome equals false. We're going to say, no, this is not a palindrome. And we're going to continue along. So all it takes is one failure, and we don't have a palindrome. And that will return true or false, whether we have a palindrome number. Now, 3003 is not just a base 10 palindrome. It's also a triangle number, or a triangular number. The way a triangular number works is it makes it the sum of numbers starting from 1. So, for example, the number 3 is a triangle number because 1 plus 2 equals 3. The number 6 is a triangular number because 1 plus 2 plus 3 equals 6. And so it turns out 3003 is a triangular number. It can be written as the sum of a bunch of numbers together, consecutive numbers starting with 1. And so what we're doing here to check for whether this thing is a triangular number, there's another way you can write triangular numbers, and that's as an integer times the integer plus 1 divided by 2. And that will always give you a triangular number. And so in that case, we're looking for the root of this quadratic formula here, or this quadratic equation here, to be equal to an integer. And so the way you check for an integer is you just take the number, subtract the integer function of the number, and make sure that those two are equal. Now, of course, subtraction with real numbers can be messy. There can be a little bit something left over in 10 to the minus 16. So we just set up a tolerance factor here. of 10 to the minus 6. And so we're checking for whether this difference is less than the tolerance. So basically less than tolerance is being considered equal to 0. And so basically that means that this equation has an integer root, and that makes it a triangular number. So what we're going to have here is a check for whether 3003 is a base 10 palindrome, and here we're going to check for whether 3003 is a triangular number. Note that triangular number doesn't matter about the base because it's a triangular number no matter what base you have. So we should get true and true for this in our celebration of 3003, and sure enough, there we go. We've got 3003 is a base 10 palindrome, and 3003 is a triangular number, which is wonderful. Now, of course, I can't just stop there. I need to actually do something with these. So what we're going to do is loop from 0 to 5,000, and we're going to check every number between 0 and 5,000 to see how many are both palindromes in base 10 and triangular numbers. So how many are there besides 3003? Let's just make the range 0 to 5,000. So we're only going to print the number if we get a number that is both a base 10 palindrome and triangular. Let's run that. And it turns out there's quite a few. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers leading up to 3003, well 9 numbers before 3003 that are both a base 10 palindrome and a triangular number. So 3003 is the 10th such number. So 0 is obviously a triangular number because you just add no numbers together, and it's obviously a palindrome. 1's clearly a triangular number because you just add 1. 3 is a triangular number, 6 is a triangular number, 55 is a triangular number, and it's a palindrome. The palindromes are easy to see because you just read them forwards and backwards. The triangular number is the piece that we really need the code to check for us. And so it's neat to know that 3003 is somewhat unique. It's not alone here in the universe of numbers, but it is pretty unique, and I'm very happy that it's our number of subscribers. Thank you all so much for watching. I will see you next time. Bye-bye.